Hello and welcome to the Objective Associates podcast. Today we'll be talking about AWS costs. That's Amazon Web Services, a complicated area and one which I'm delighted to say we have someone who knows a lot about it. Fraser Ingram joins me. Fraser is the CTO at Objective Associates, and of course I should introduce myself. My name is Alec Ogilvie and I'm Managing Director at Objective Associates. So, Fraser, I guess the first thing to talk about is really the big choices when you've moved to AWS for whatever reasons. We can maybe cover that in a different episode as to why you would move to AWS. But I guess the first thing you look at is probably, the database types that you could potentially use. How does that work? How do you make that choice?
Yeah, sure. You've got a few options when you're looking at the database. You could either do it the way you'd probably normally have it in a data center. You've got virtual machines hosting databases or physical machines hosting database servers, be that Microsoft SQL Server, MySQL, or many other database technologies. So you can still do that on AWS, and how you do that is by setting up EC2 instances. You set them up, choose the instance size that you'd want. So effectively choosing the amount of memory that you've got, the number of CPU cores that you've got available to you. Or the other choice, so that's EC2, you would choose those instances. Or the other way to do it is look at using the RDS service from Amazon. The RDS service is effectively a cloud-based database that you generate the database, you manage the database, but you don't manage the servers that go along with that. There's advantages to using RDS, and that obviously what's happening there is Amazon are managing the database servers, if you like. They're dealing with the mirroring, they're dealing with resilience aspects of that. If you're doing that in EC2, you're having to put that together yourself. So maybe setting up mirroring, transaction log shipping, and all that kind of stuff that you would normally do when you're setting up database servers on a traditional data center.
So when it comes to costs on that then, strikes me if Amazon in the RDS database environment are doing a lot of that mirroring stuff on your behalf, then that must be a more expensive option for you.
Yeah, I mean, you are paying for Amazon to set up the resilience for you. So you are paying Amazon to do that for you, as opposed to an EC2 setup where you're doing that yourself. So in an EC2 scenario, you may need, if it's Microsoft technology that you're using, you would need 3 databases. In that case, you would need your primary, your mirror, and a witness server. Whereas in RDS, that's all done for you. All you've got is a database to connect to and use the database.
And if you're not using mirroring, or if you choose not to have mirroring for whatever reason, it sounds then that the EC2 would be a very sensible way to go. And presumably it's still pretty resilient. It's not going to fall over on you or anything, is it?
Yeah, I mean, you can set up and use an EC2 database. So, and that would be the same as setting up a single database server as you would do in a data center, if you've got a database set in your office.
All right, so there's the two choices. Then you do RDS or you do EC2, which is elastic computing.
Yeah, elastic cloud computing.
Elastic cloud computing, thanks Fraser. Okay, so that's the two choices. Regardless of that choice, you're going to have to store the data someplace. So what's the options there?
Yeah, I mean, when you set up an EC2 instance, you get a little bit of storage effectively for your operating system. For some instances, you also get effectively some temporary storage that's local to that machine. But that is temporary storage, and it will get deleted when the machine goes down and back up. So really what you need to do is set up some EBS storage, and there's a number of choices in the EBS storage that you've got. You can use traditional hard disk drives, or you can use SSDs, and there's a number of options within both of those as to how fast you want them to go.
Okay, so the costs associated with that storage then, I guess, whether it's SSDs or any other kind of conventional storage, how are they charging for that? How does that work?
You're really charged. So if you're looking at traditional hard disks, you're really charged per gig. So effectively you're charged, if you want 100 gigs worth of storage, you're going to get charged for 100 gigs worth of storage. For SSDs, you've got another option though. You get charged per gig, but you can also look at the IOPS that you need available. So if you need really fast storage, then you can bump the IOPS up and get charged more for that 100 gig.
All right, so IOPS, explain to me, if not the listener, what is an IOP then?
IOPS are really the if you think about it as the rate in which you want to read and write data from that drive. So the more IOPS you got, the faster you can read write data from the drive.
All right, so this is really, it's a notion of processing capability in the end, isn't it? Because if you can't get the stuff in and out of the system, then you're not going to be able to process. So your system's going to slow down, I guess.
Yeah. So, if you've got maybe a database with heavy read and write operations, then looking at the, being able to speed up the IOPS on that would be fantastic.
So there's a couple of price models that are associated when you're actually choosing your AWS setup. You want to run through those for us and explain the kind of pros and cons of each?
Yeah, so on your EC2 instances, so effectively your normal server setup as you would see it, and you would normally have had it in your data center, a virtual server effectively, you've got a couple of ways to pay for that, or a few ways to pay for that. You can pay for it on demand, so you can pay for it, if you want it up 24/7, then you pay for 24 hours worth of access of that every day of the week. Okay, so that's your normal, okay, I've got this server up and running and I'm always having it up and running. So you pay for it. You would set an on-demand instance in that case. To bring the cost down on that, if you can commit to running that for a period of a year or 3 years, there's ways to bring down the cost on that up to about 20%. So you buy a reserved instance in that case as opposed to an on-demand instance.
All right, so you could imagine the situation where if you're moving to the cloud or you've got a new service or a new system you're installing, then you could potentially say, right, I'm going to set up an on-demand type model.
Yeah.
And then figure out over the space of a couple of months or a couple of weeks even, I guess, how much that's going to cost you and whether it's worthwhile going to a reserve model where you may be committing on the longer term, but you're getting a discount on the overall price.
Yeah, absolutely.
And is it easy to switch between those two business models?
Yeah, if you've got an on-demand instance running and you've got it up and running, then all you do is buy the reserved instance. You don't have to shut it down, your existing instance back down. You don't have to do anything like that. You just say, okay, I'm now buying a reserved instance of that same size, and your costs for your on-demand instance will effectively fall back down to the reserved price.
So that really helps to take the risk out of building a system on AWS, because you can effectively suck it and see before you commit to any long-term costs.
Yeah, absolutely. If you think that you need a pretty small server to start off with, or a pretty chunky server to start off with, then you spin that up, get it running, and see what it does. You see if you're using the full CPU power, see how it's going, or do you need a bigger instance than that, or do you need a smaller instance than that? And you tune it at that point, and then once you've got it all settled, then you can look at buying the reserved instance and settling the costs on that. There's actually options as well within the reserved instance to convert it to different instance types as well. So,
all right, so you can increase its processing capability or the storage around it.
Yeah. Effectively, if you've got a reserved instance of, say, a medium instance size, then you can look at changing that to maybe a 2XL, and there's ways to do that within AWS. There are certain parameters around about what you can change to what, but it can be done.
And you can go up and down. You're not locked in if you go up the way.
You can go up.
Right. You can go up. All right, buyer beware perhaps. If you are then in an environment where you want to go up or you want to move to a reserved instance, how do you know when to do it? How are you monitoring the behaviour of the instance that you've got or instances you've got and deciding when that time is appropriate? How can you see what's going on? Well,
there's a couple of ways to do it, okay? So if you look, the really simple way is, okay, are your servers performing okay? and are you happy with the utilization that you've got in those instances, okay? The very simple way is going into Cost Explorer within your AWS dashboard, and if you've had it running for over a week, you'll start getting recommendations from Amazon as to which instances would go on a reserved instance as well, and how much money it would save you.
Should we believe that?
If you're settled in your infrastructure, then it's a really good way of looking at it, okay? But if you're looking at your instances and going, actually, maybe I'm underutilizing that instance, or maybe it's not quite coping with what I've got running on the instance, then maybe you look at first upping or downsizing. Effectively, what you really want to do is you want to make every instance the right size for what's running on it. Okay, so we talk about right sizing the instances. Okay, so make sure that if you've got a 2-core instance, then it's utilizing those 2 cores. If you've got a 4-core instance and you're not using the CPU very much, then look at changing it. Look at bringing it back down to a smaller instance size and utilizing it fully.
So presumably all the CPU usage, that's getting reported to you in some digestible manner. Yeah.
So within your AWS console, you get some really good stats when you look at the instances. Okay. You've got CloudWatch as well, which CloudWatch will let you set up alerts and monitors on CPU usage. It'll let you set up monitors on, if you're looking at T2 instances, it'll let you set up credit watches and things like that. And I'm sure we'll talk about T2 instances in a second.
Nicely queued up, I guess. T2 instances, obviously they must be something of interest to the folks. So explain a wee bit about them now.
So if you've got an instance running on AWS, say you've got an instance with 30 gig of memory, 4 cores, you've got to sit and run, but you're going, actually, most of the time that instance is low CPU usage, okay? So, I might need all the memory, but I'm not using the CPU all at full tilt. So there's ways to reduce that and convert that instance from its current instance into a T2 instance. What a T2 instance lets you do is it's cheaper than the equivalent general purpose instance for a start, so it's cheaper per hour than the general purpose instance. But what happens is that as you're using the CPU, you either gain or lose credits on that CPU. So you start off with a set number of CPU credits, there's about 60 odd, and if you're underutilizing the CPU, then you gain credits on that. If you're overusing the CPU based on a threshold, then you will start losing credits. And the aim, obviously, is not to get to 0 credits. If you get to 0 credits, the machine will start to get throttled.
All right, I'm trying to digest that. I guess it sounds a bit like a leaky bucket where somebody somewhere's pouring water in at the top and there's water pouring out the bottom, and the idea is to find some kind of equilibrium.
Yes.
Okay.
Yes.
Right. I'm sure that doesn't help anybody out there.
And monitor it.
And monitor it, okay.
And monitor it. Make sure you never hit 0 credits. What we do in that case is we've got our T2 instances set up with CloudWatch to monitor and make sure that we don't go below 50 credits on any of our instances.
Okay. We're almost out of time, but given that we're talking about how to maximise the usage of AWS and minimise your spend, the last thing that's probably worth a quick mention is Lambda, because that strikes me as almost science fiction.
Oh, Lambda's fantastic. I love it. It's absolutely brilliant. So what Lambda does is it allows you to execute a bit of code for up to 5 minutes. Okay, so you can basically say, here's a bit of code that I want to run, here's the data I want to give it, and run this for 5 minutes and come back to me with the results. And then you're effectively paying for what you use. Okay, you're not running a server, you're just firing a data packet and getting it to run some code against it.
So basically Amazon's got a whole bunch of processing power, and you chuck this code at the thing, and it does it. And as long as you do it within 5 minutes and tidy up at the back end, so that you complete your processing safely, you just chuck it when you need it.
Yeah, it's fantastic.
So great for real heavy peak load kind of moments when you really need to do something fast and you've not already pre-contracted that processing power, I guess.
Yeah, I mean, it saves you running up an EC2 instance to go and run something for a couple of hours. You just, chop it down, run it on Lambda functions, and get the results back.
And you get price information on this regularly so that you're not just spending the finance director's budget all the time?
Yeah. So it's worth keeping an eye on your AWS console. So you've got Cost Explorer within within the AWS console, and it tells you effectively what you're spending.
Right.
Keeps you up to date. So today I can see what we spent yesterday.
All right.
And yeah.
Okay. Right. Folks, we've covered a lot of ground. I should thank Fraser. That's probably been about 15 minutes that we've spent chatting about AWS costs and the general structure of how an AWS system should look. So, to recap, there's RDS databases, there's EC2. RDS sounds like a fully managed type thing from Amazon, which is pretty expensive compared to EC2. You choose the instance that you want. You step up the ladder as you need to get more processing power, but with CloudWatch you can monitor the usage. Sounds like IOPS are pretty important. If you get the IOP count right, then you can do as much processing as you want. Get that wrong, and your system will die on its feet by the sounds of it. And then there's this Lambda thing, which is throw some code at Amazon and it'll run it for you. So, yeah, pretty good. I mean, is that a rough summary, Fraser, do you think?
Yeah, that's pretty good. We'll take that.
A pretty rough one, I guess. All right, okay. Well, thanks again, Fraser. And listeners, we're hoping to do a few of these over the next few weeks, so please check in again. This has been Alec and Fraser talking about AWS costs. Thanks very much.
Thank you.